Welcome to this episode of the AEC Engineering and Technology Podcast, a podcast dedicated to helping engineering professionals find technology that fits their needs. In this episode, I'll be talking with Anande Bergman, Chief Growth Officer and part of the founding team of VIKTOR. He has a master's in aerospace engineering and more than 10 years of experience in automating workflows in structural engineering and manufacturing. In this episode, we'll be talking to him about workflow automation and design and the creation of VIKTOR. We'll explore the importance of automating workflows, potential challenges, and Anande's vision for design automation. Anande, welcome.
Thanks, Nick, for having me here and hosting this podcast.
Absolutely. Great to have you on. How's everything going?
Yeah, it's going well. We are super happy because today was like a special day for us. So from today, we released like a big feature. We have been working since a long time on it. And it's like we've made possible for everyone in the world to create and share apps for free on VIKTOR. So yeah, I'm quite happy about that, and I'm really looking forward to all the open source apps people will be creating and sharing with the world.
Yeah, and as we were kind of discussing earlier, right, this is a big opportunity for a lot of people out there, right? So why don't we get started? Because I know we've got a really good conversation ahead of us here, but why don't we start with a little bit more about your background and what you're doing on a day-to-day basis?
Yeah, so well, my name is Anande. I'm the Chief Growth Officer at VIKTOR. I have a technical background, so I did a master on aerospace engineering. And yeah, I've been automating all kinds of engineering workflows or design workflows for about 10 years. And we, like as a team, have been doing that also for a long time in like many different sectors. So just to give you an example, we do that in geotechnics and structural engineering, also big infrastructure projects, but also in real estate or processing industry of manufacturing, offshore, maritime. So we have been doing many projects in many different industries and different applications. So it has been great to see everything that's happening around the world.
Which is really cool, right? Because you guys aren't just focused on one subset of one niche of engineering, right? Because it sounds like the tool you came to talk about today, and along with the concepts along the way, VIKTOR, it is really something that's versatile and can be used by a pretty wide spread of individuals, right?
Yeah, exactly. So we created a tool, so that's VIKTOR, and maybe it's nice to tell a bit of the story behind VIKTOR to give us some context. And yeah, we created VIKTOR 6 years ago, basically as like out of frustration we had in our own work, So we were like a bunch of engineers. We all had our masters, and we were working as consultants and doing all kind of structural engineering calculations. And yeah, at a certain point, it was just boring. The world was full of boring, repetitive tasks to be done. And we started automating those tasks with Excel sheets and Python and all kind of tools. And then we had like also 2 production companies, and we saw the same. So also we have a bridge building company and a flange building company. And there we see it again. So a lot of things to be automated. And at a certain point, we really realized that what was like our expertise was really automating stuff, was not running a production company and not doing like consultancy work. So we started offering that like as a service. And quite early in the process, we spent a lot of time to really think about, okay, what will be like the best solution to create like automation tools. And we got to the conclusion that the best thing we could do is really making web applications, because you can share it easily with the world. So you just need to have internet access to see them. You can make them very user-friendly. So we started doing that, and we did that for like 3 years, mostly with construction and engineering firms. And at a certain point, some clients approach us and say, hey guys, look, we really like your tools. They're delivering a lot of value, but we want to make them ourselves. Is that possible? And that was really like a big shift. So that was like almost 5 years ago. And then, we basically created what is now known as VIKTOR. And VIKTOR is a platform wherein engineers like me, or maybe like you, that have some coding experience, but are not like on the level you will require to work on Google. So you have some Python experience, can make really professional web applications, and we provide them the tools to do this, and also to share those applications with their team and with a bigger part of their organization.
And what you've stated there is really interesting, because I'm sure if you ask any number of engineers, right, there's some amount of repetitive tasks or something that can be better automated, although they may not necessarily know the best ways to do so, right? And that's one of the big keys here at AEC Tech on this podcast, is figuring out ways to make the highest and best use case of kind of the time of engineers, right? And I know you've got a little bit of a motto here, right, that when I heard really resounded with me, because there's just so much, right? There's so many things that we do as engineers that can be automated or can be more efficient. But just to kind of frame the context of the episode before we get any further, could you just share with the audience kind of what your motto is in regards to like VIKTOR and design automation?
Yeah, so the slogan of VIKTOR, it's automate the boring, engineer the awesome. And we get a lot of good feedback about that. So people really feel it. So people that's there doing their job and having these automated things to do, they understand what we are about.
Right. So, and now let's talk about VIKTOR, right? So what are kind of the unique features or aspects of VIKTOR that are differentiating it from other automation design tools in the market?
Yeah, so when I think like about all the tools that are available, I see that there has been a lot of advancement in creating new tools that help you automate like a part of your workflow, of they automate it for you to say in some way. And those are mostly like in a niche or like in a specific domain. And when I look to VIKTOR, we want to do the contrary. We want to enable engineers to automate the work they are doing. So we want to empower them and give them the tools to automate. And we want to do this as open and flexible as possible. So you can really use, for example, integrate with other software platforms or integrate with finite element software, so with Revit, with all kinds of tools. And you can also use the whole Python ecosystem, which is really powerful. So for people that are into Python, or are not into Python, so Python is the most popular programming language in the world at the moment. And this like a huge ecosystem. So if you want to do something for geospatial information, you have tools for that made in Python. If you want to do something with numerical calculus, there are tools for you. So there's a lot of stuff you can use. And we want to have an open system where everyone can use those tools and integrate their workflows. And I think that makes it really unique. And on top of that, we have like a really strong focus on enabling people to make like really user-friendly tools. So tools people can use. So maybe if you're a civil engineer and you make a tool that even your colleague of the sales can use it, for example, and that you have a system of sharing those tools between your team and your organization, which is kind of a, let's call it a private app store where you will find all the apps your team has, and then you can say, okay, some people can see some apps, the other ones cannot see it, and you can see all kinds of statistics. So I think that's really unique, that we provide you more a system and a box of digital building blocks, which you can assemble to basically automate the thing you are doing.
And it sounds like you're really just making things accessible for, let's just say, the general engineering population, right? Because as someone personally, right, who knows a little bit about Python, but as you alluded to earlier, right, like many of us are just not at the level where we're software developers. So it sounds like you're just taking kind of that engineering brain, that logical thought process, and then making it just a lot simpler to communicate with a computer to complete design automation tasks, right?
Yeah, right. So we want to make it very accessible. And just to give you an example, like 2 months ago, we had we organized a minor with a university here in the Netherlands. And those were students that didn't have a Python training yet. So they had 2 weeks of basic Python training. and then they had like 4 weeks to create like a project on VIKTOR, and they all succeed making those apps. So I think that tells a lot about the level of programming skills you need to have to make your own apps. And that's the nice thing, you know, you don't need to be an expert. You can focus on the thing you really know, which is designing bridges of buildings of whatever you're doing, and you don't have to crush your brain thinking about all this like IT stuff around it.
Yeah, which is great because, right, you as an engineer just want to focus on the engineering and kind of have those tools accessible to you. But let's take a step away from VIKTOR for a second and just talk about the concept of design automation in general. It's like, what's your vision for design automation, and why is it so important that you can automate these workflows?
Yeah, so if I think about it, I think it's best to reflect about how we do stuff first, you know? So if I look at the typical engineering project, let's say we're making a bridge or a tunnel of anything, you have like teams that have like different responsibilities. So let's say structural engineering, you have your technical engineering, you have someone doing the drawings, the planning, the cost calculations. And what we see is that those disciplines, they work together and they communicate on all kinds of ways, you know? So they're like islands communicating with each other. They're sending each other mails, they're calling each other, they're sending Excel sheets or whatever. And to get like to a final design, they're iterating the whole time. So you send me like a new specification of the budget got reduced, and there we go again. You have to make like a new design and update those designs, a new report and a new drawing, and you keep iterating until you get to the final solution. And of course, like a big first step, it's like making that easier. So you see that a lot of people are using like parametric design, are making stuff in Dynamo, of Grasshopper, of Python scripts or Excel sheets to make their own work like easier that enables them to iterate quicker. But I think like there's a lot of gain to be made when you integrate those different disciplines. So in my ideal scenario, I will think about like a central system which executes those tasks automatically. So where all those calculations are like done automatically, and where you, as a group of experts, can basically run different scenarios, analyze results, basically take decisions, you know, use your knowledge to take decisions and don't spend time running calculations. And I think that's like the ideal point where we want to get, where you have like a team maintaining those systems, taking decisions, making sure like that the design process gets improved, that the designs get improved, and that they don't waste time making those calculations. And I think when you reach that point, you will have like tremendous benefits. So of course, like the most obvious is that it will be faster, but also you will have a lot of flexibility. So what's typically is that things change in time during projects, and having like this automated system enables you to basically on the click of a button get a new design. So last minute changes will not result in delays in your planning, for example, or maybe to a design that's not optimal because you have optimized the system, you know, so you will always get like a good result out of it. At the end, you will have more time free for getting better designs, for running different scenarios, and you will reduce risk and have better designs and save materials at the end. So I think, that's the thing we should try to achieve, from the engineering perspective.
And which is great, because as the engineer, you're not, like you said, you're not just running calculations and just crunching numbers, right? You're making decisions, and you're using your engineering judgment to kind of figure out how a project's going to go together. And I'm just thinking of an example, right? If you're a building designer, right, and you need to be in constant contact with either your geotechnical engineer or whoever's designing the foundations, right? They need loads from your building. Well, if you can rapidly iterate through building designs based on some specifications from an architect, right? Maybe a couple weeks of back and forth between a group of engineers can go down to, I don't know, maybe a couple of days, right? But that's just kind of scratching the surface, because it sounds like there's a lot more possibilities than just that one specific example, right?
Yeah. So there's a lot to be done. There's a lot of potential, and yeah, I can explain some cases. Maybe if we have some time later. And I think maybe people will be asking, okay, good, nice to hear this like system you want to achieve, like this automated system, but how, so that's the big question we often hear from clients. Okay, that sounds good, but how can I approach this,
Yeah. And I'd even say, why don't we step right into kind of the concrete, right, and the hard examples. So now that we've talked about design automation at a high level, like, can you talk about specific examples in using design automation so that users can start getting into the details and like their specific use cases?
Yeah. So I think like the specifics will depend a lot on your case, of course. So automating foundations is totally different than automating like a bridge. But we have been in many projects, and if you look from a distance, you see at least that they're like let's say like a roadmap. So there are some steps you have to take if you want your automation project to be like successful. And those are like 7 steps, and I will mention them really quick, and then we can maybe talk a bit more about those steps. But basically, the first step is, of course, digitalize. So if you're working on paper, then you will have a hard time automating anything. So that's the first step. The second step, which is like super important, is you have to standardize your process. And maybe you have a standardized process. So what we mean with a standardized process is that so that you basically follow the same steps to get to a solution. And that doesn't mean that your solutions will be always the same, or that you will only offer like 10 different solutions and that's it, but that you follow the same steps to get to that solution. So for example, I take software A, I put those results in software B, and then do some cost calculation with this Excel sheet. And okay, but sometimes I do this other. So finally, what you want to do, it's like come together as a team and maybe make like a flow chart, saying, okay, this is the way we work, and this is the way we share information. And think about that and say, okay, will it be not handy to maybe do stuff different and have like an ideal workflow which you want to automate? So that's the first step, having like a standardized process and understanding the process very well. The second part is integration. So you have this workflow, you have all these different parts that are communicating with each other. You want that information flow between those components, so between software A and B, for example, that you can do it in like an easy way. So you don't have to copy paste those results into the software, but you have like some script or something that helps you transfer the data between those points. And you want to have that for all parts of your system. The next part will really look into that and say, okay, that's great, I want to automate this. So you want to follow those steps automatically. So you can execute all parts of your workflow, let's say with a push of a button of running a script, of running a few scripts, but without like manual steps or having to send a mail or having to call a colleague. And then, of course, you are able to generate this design very quickly, but that doesn't mean you have a good design, So that's just the basis of it. The next step is really optimization. And optimization is really finding the best solution you can. So it's running this workflow of this design system many times and really seeing what's the best solution and be able to like evaluate different scenarios to say, okay, this is the thing we really want, optimize the design. And the last 2 steps are like a combination between like technical things and really people, So I think like a big factor in automation is also people. It's not only technology. So I think step 6, it's really distribution. And with distribution, I mean having a system that helps you share those tools. So having a system, for example, what we see typically is that you have a drive, a company drive, where you drop some Excel sheets. But that's not a really good distribution system, because people can basically just copy paste those Excel sheets and take them home. So your IP is not protected. Or, for example, you can make an Excel sheet, I can change it, and there's no way to make sure you are using the last version of the Excel sheet. So having a good distribution system is super important. So think about that. And the last step is really thinking about the impact you can have, the bigger impact you can have in a team. So it's great you have created tools in Python, Dynamo, Grasshopper, or Excel sheets, but if you are the only one that's able to use them, then your impact is limited. So step 7 will be really democratization. So how you will make tools that other people can use that maybe don't have the same technical skills. And the answer for that is most times have a nice user interface that people can use, and make sure that those people can use those tools between like safe boundaries. So I think that's like the roadmap. And yeah, the specifics of your case, that's something you need to discuss as a team, So that's the part where you say, okay, this is my workflow. How can I improve my workflow? What's like the big dream? And there you go and follow this roadmap. And maybe the last thing I would like to say about it is that it sounds really big, maybe. So it sounds like a huge work, but it doesn't have to be. So I will say, think big. So try to make like try to have like a goal. So this is what we're going to achieve in 1 or 2 or 3 years. But please start very small. Start with one little thing. Try to go through this whole process, and try to involve the end user in this. So if you want other people to use these tools, involve them very early in the process, because that will make them feel part of the process. So it's not your tool that they have to use because you say, it's a tool you're making for them. But it's also like a very good way to see if your tools are really providing value and where you should change stuff. So this whole roadmap, it's really like an iterative process. You can do it in small steps and start building slowly until getting to the point you want to get.
Which is fantastic, because you've essentially laid out this roadmap, right? It's not specific to any one use case or any one subset or niche of engineering, but it sounds like you've thought a lot about this in the context of how do we make this product, right, VIKTOR or design automation, accessible to the masses without constraining someone down to, well, if it's a geotechnical workflow, we're doing this. If it's a structural workflow, we're doing this. You're really giving power to the users is what it sounds like.
Yeah. And maybe, Nick, I think if people like to know more about this, we wrote a white paper and a blog talking about this, like about this roadmap, about like really working like collaborative parametric design and how you can approach it and what the impact is. So if it's fine with you, Nick, we can add those links in the podcast so people can read more about this if they're interested.
And to our audience, if you are, as always, right, we'll include any links to materials, papers, books, et cetera, right? In this case, the white paper in the show notes. So you all will have access to that in the show notes.
Yeah.
So one question I have, right, and this is going to kind of roll into our next question, is going to be challenges in automating workflows. So one piece of automation that I always find really interesting is edge cases, right? Edge cases or human involvement. So my question about, design automation and VIKTOR is, how do you guys handle edge cases? But more broadly, right? Users are going to run into challenges with design automation software, right? We see it all the time. Yeah. How are you guys handling these types of challenges that users run into?
Yeah, so I think that's one of the challenges. And I think I think you always have to be like honest with yourself and think, how far do I want to go with automation? So I will never say automate everything, because at a certain point, your investment will be not worth. So if you are trying to cover all cases, you will have to spend a lot of money creating the system, and you will probably never get it back because you will include a lot of like edge cases into your system. So I think like the reasonable thing to do is creating tools that maybe solve 95% of the things you do, and make those tools in such a way that those edge cases can also be handled. So for example, you could think about making like a parametric configurator of a building, which follows a certain design style you have as a company, of a sales and design system. And you can use that, and maybe at a certain point you can say, okay, that's enough. That's not, I will not go further in my automation development. I will just download this model and do it like the old way, and change this model manually for those edge cases, or for those little pieces that are not fitting into the automation model. So I think that's really the key to handle this in a proper way, having a system that works almost always, and giving people the flexibility to handle those edge cases manually, to say it somehow, but at least 90% of the work it's done for you, so you will be much quicker.
Which is really Pareto or fractal in nature, right? Because it, 80-20 principle is often referred to here at the Engineering Management Institute, is you can perhaps spend 20% of the effort automating 80% of the work, right? But that last 20% of edge cases or parts where just automating the human involvement away is really challenging and really time consuming. Sometimes it just doesn't make sense. That's what I'm kind of getting from what you're saying.
Yeah, and it does make sense, but it's also a big risk, because what I see sometimes is that people try to make tools that cover like all cases, and they spend like months and months and months and months creating this tool, and it becomes a huge monster. And at the end, if they cancel the project, so because it's taking too long, or if they don't see the value of it's really error prompt because there are so many variables in the system. So I will really, encourage people to really start small and work on something that you see very often. So this 80%. So if something is really able to automate 80% of what you do, go for it. You don't need to automate 100%. It's just here to help you, to do your help. It's not to replace you. Tools will never replace you.
Which is a great point, right? And one of the fears rightfully founded is that these automation tools are here to replace us as engineers, right? But the way I've always seen it, and I'd like to know what you think about this, is if without a very capable engineer in the driver's seat, a lot of these automation tools just aren't useful, because there's so much nuance and human involvement outside of just running the numbers, right? That it is required to make projects successful. And without competent engineering, really all of this falls apart.
I totally agree. So I think those tools are here to help you, to free you from as I say, the boring stuff. So you can make better designs, but you are the expert. You have the knowledge. You know how things are built, how things develop in the field. You are the one talking with the client and making decisions. So this is just a tool to help you make those decisions and to help the client in a better way, for sure.
And speaking of, right, those specific examples of either interacting with the client or getting in the field, right, and understanding how things are built, why don't we talk about some real world scenarios about how VIKTOR has been used, and if you have any that come to mind. But I'm curious myself, right? So can you share some good examples that you've seen, either from yourself, your colleagues, or customers in the past?
Yeah, so we have quite a lot of examples, but if I put them like in buckets to say it somehow, you will have like the mega projects, so the big like infrastructure projects. You have like maybe the tools you make because let's say a colleague, it's depending on you, and he is bugging you each day because you have to make this calculation so he can make an offer, and at the end you end up making these tools so this colleague can do it themselves. And you have like maybe a third category, and those are like people or businesses searching for new business opportunities. So, for example, you are a consultant or a freelancer, and people basically pay you to do some calculations, and the thing you deliver is mostly a design, a report. But you can also make a business model of it, and you can make, for example, an app and ask people a fee for accessing that app, and that is much more scalable than you doing this reports each time. So those three cases, I have some examples. For example, if you think about the mega projects, we're working on automating the design of the world's longest submerged tunnel, which will connect Denmark with Germany. And that's such an interesting case because basically there's so much to be optimized and so much data flowing in that case that they need these automation tools. It's not possible to do it anymore without automation tools. So what you will see is that this tunnel, it's like 18-kilometer longs, and it's made of 90 sections, and those sections are like 210 or something, 220 meters long, which is at least higher than the highest building we have here in the Netherlands. And each of those sections have kind of the same cross section, because of course you have the lanes and the tunnels and everything, but they are located on different portions, so they have like different soil properties at different depths. So you will have different external pressure on the tunnel. So basically, if you don't have this automation tool, what you will see is that people will do something very classical engineering, that is taking the worst case and calculating for that, or calculating two worst cases and basically making a whole tunnel based on that. That will be so expensive, so expensive. So they have created this tool that automates the structural engineering of the tunnel. And they're really analyzing each section, each I think 2 meters. They make a different section and they analyze the whole tunnel, and they're really getting like the most of their engineering knowledge to save like tons of steel and concrete, and saving like tons of CO2 and movements of trucks and cranes. And it's like the impact you have, it's like huge. And one of the challenges that they have, of course, is because they have that many sections, and they have like, I don't know, like 200 load combinations for every section. The amount of data that's flowing through such as a design it's enormous. And the chance of making like a mistake because people use a wrong version of the data, it's growing with amount of data, of course. So they also need this centralized system where all colleagues can access. So they call it like a single point of truth, so you can access this app, and all the information regarding the latest design of previous designs, it's stored in that app. So all colleagues are working there and pulling data for doing other stuff. So yeah, I think that's a super good example, and we have a few of those. So we have like for tunnels and dikes and highways, people are creating like this specific tool for this project, and the return of investment is really in that project itself. So they make this tool and they include budget doing tendering of those projects to really make automation tools, and it's a great idea. Everyone should be doing this, and then. Yeah.
And it's a great example because, if you think about, go back before we had computers and structural analysis software, and everything had to be done by hand, right? There's just obviously time constraints. And I think that's just kind of part of classical engineering, like you mentioned, where you're taking the worst case scenario and applying it globally, just because you realistically don't have the time to run every single case, like pretty much down to sharpening your pencil, right?
Mm-hmm.
But now with technology and how it's progressed, right? You as the engineer, you're it's almost like you're managing a team of individuals doing the calculations for you. It's just that it happens to be software, right? That's doing it for you. And now you can multiply your efforts so much more. And there's like you said, right? Because you're just one person in an office running design calculations, but think about how many, hundreds of people's jobs that affects, right? Material, time, scope, and all of this costs ultimately to an owner. And it's really amazing what we're able to do now that we just weren't able to do in the past.
Yeah. So the impact is huge. And of course, you can imagine a lot of people are thinking, okay, but I'm not calculating the longest submerged tunnel in the world, because there's a reason why we call it the longest. So not everyone is doing this. But you can also have impact in like your daily operations. So for example, we have a client that made an app, and what they do as a core business is installing their foundations contractor, but with an engineering office too. So they do basically the whole calculation. Clients come to them and they say, okay, this is like a preliminary pile plan. So, well, in the Netherlands, almost everything is on piles because the soil is super bad. So you need to have piles. And they come with this preliminary design, and they have so much expertise and different piling systems that they can help the client to make a better design. But they didn't have the time to do this because, of course, when a client comes to you and says, hey, I want to do this project, it's just a quotation. So that basically you're not able to spend too much time in this. So that was the reason for them to start going into automation. So they start creating tools that enable them to basically create an optimized pile plan. So, and they done that. So they automate the whole system. And now when a client comes, they're able to say, okay, we have a better solution, that it's also stronger, but also cheaper and faster to place. So that alone is a reason for clients to go to them, because they know they will come with something better and cheaper than you were counting with. And it's a really great case because they really took it to the next level. So for those that are into foundations, they will know that basically the cost of a project, it's basically defined by two things. One is how much piles you need and how big they are, so basically material. And the other one is how fast can you stamp those piles in the ground. So we have this big machine stamping those piles in the ground, and they're quite expensive to have and to operate. So those are like the two factors that determine the cost. So, and the first one, like how much piles you need, that is something like engineers can calculate properly. So there are like, that's something that's known how we do that. But knowing how fast you will be able to put those piles on the ground, there are no models for that. There's no software for that that's able to help you with that. And what they did was supply the machines with sensors. So they were able to measure the force and the speed on how fast they go. And with that data, they made like a machine learning model. And with that, they are able to predict how fast based on the soil properties. So they make this the CPT, the concretization test. They know which kind of soil they have in a project, and based on that and previous project data, I will also to have a quite accurate indication of how much time it will cost. So now they have the two factors, materials and time, and this gives them like a huge advantages in comparison with other companies that are doing like something similar. So the service they provide, it's amazing in comparison with other.
Yeah, and just think about how that translates to dollars, right? And you had mentioned earlier about, maybe an engineer develops an application that their sales team can use. Well, this is great, because imagine your salesperson collects some, preliminary information as they're building a proposal for a client, and instead of passing that to their engineer and their engineer getting back to them in a week, right? They sit down together for, a meeting, and there's some initial input, maybe the sales team does, and then the engineer is there to just verify the output to make sure it's realistic, right? But all of that's only possible because of, right, as you mentioned, design automation, the sensors, right, the machine learning model, that basically it gave you another person, right, to do that work, but it's really just a computer doing it in the background, and they're not constrained necessarily by time or other demands, right? And that allows your engineering team to kind of free up and do other things.
Yeah, and I think that what fascinates me the most of all this project is most times there's no new process of new knowledge that's developed. So it's the thing you're always doing, but it's really getting the max of it. You're really unlocking the potential you have as an engineer to make really good use of it and not be bound by constraints in time of that kind of stuff, you know. So that's the nice thing. It's you don't need to change anything. You just need to make this tool and use your knowledge in the best way.
And you do it once, right? You may need to refine it, but you're gonna see a huge kind of return on your investment. But now we've kind of talked about what has gone on with VIKTOR, right? What has gone on with design automation to this point from your guys' point of view. What are you excited about in the future regarding whether it's design automation or VIKTOR or kind of just the industry in general? Like, what are you keeping an eye on and looking out for?
Yeah, so personally, as I said at the beginning of the podcast, I'm super excited about that we made it possible for everyone in the world to create automation tools and deploy them. So put them online and share them for free. So I'm really looking forward to, I think, a new movement that will be that it's like on the beginning of this big movement of people that will be creating apps and will be sharing knowledge in that way with each other. And I think also like cooperation. So I see that engineering is opening to more cooperation. So for example, here in the Netherlands, there's like a consortium, because between the 8 biggest contractors, which are competitors basically of each other, and they decided that they will make digital tools together because it is cheaper and you will get better tools than making this alone. And that this is happening is for me fascinating, you know, that we're opening to share this knowledge and to really think, okay, guys, if we really want to advance as a society, we need to share, we need to do something together. And there's enough to do for the world, you know, there are enough projects to do, there are enough things to do. We will not have trouble with it. We will move forward, all of us together. So that's fascinating. And from the technology side, of course, IE and in engineering, I think that there's a huge potential there that we are not really maxing out yet. So there are that many possibilities for artificial intelligence on construction we can still make use of. And the foundations was one of the examples, but there are many more.
And we say it a lot on the show, right? Where the amount of work that is available in the market far exceeds what any one company is able to take on, right? Firms have huge backlogs. You know, it's the number of qualified engineers isn't exactly skyrocketing, right? Especially in like this traditional civil, mechanical industries. So there needs to be a better way to do things. And that common theme, right, is one that we try to share here is we need to get better, right, as an industry, as a profession, and right, all these types of tools and technology that we bring to the audience is just one way to do that. But Anande, it's been great having you on the show, right? Where can our audience find out more about you, like maybe social or a website, if they want to learn more about what you're up to and how they can use design automation tools like VIKTOR?
Yeah, so if you want to reach me personally, you can do it through LinkedIn. And I think the easiest is just to drop a link somewhere in the description. If you want to learn more about VIKTOR and what we're doing, we have a website that's VIKTOR with a K of kilo.ae. There we have like also, we explain what the product is, but also we have a lot of customer cases and blogs where you can see how you can apply it to your specific case. So we have a lot of cases in different industries, so there you can take a look. And yeah, I think people interested into that, I can leave maybe some good pieces to read. So I will leave the link to this blog about the roadmap and what you can do about it, and about a white paper on parametric design, but what's like the future of parametric design. And we can leave those link there. And then, yeah, if you're interested into that, you can read that and you will have like nice insights into what's happening.
Excellent. Well, again, hey, it has been great having you on the show. And we, at the end of every episode, we make the offer, right? We're here to help at EMI. Our guests are here to help you guys. So please, please, please reach out if you have any questions about, right, VIKTOR, design automation, or maybe there was something else this episode sparked. We are definitely here to help you. But Anande, again, great having you on the show. Thank you so much for joining us today.
Yeah, it was a pleasure to be here, and thanks for hosting the podcast again. It's super nice that you take the time to share like knowledge with the world. That's something I appreciate a lot as a person.
Yeah, absolutely. All right, until next time, thank you.
Okay, bye-bye.
Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during the episode. Until next time, I wish you all the best in all of your engineering and technology endeavors. Thank you.